Hi, in this video we are going to talk about cycle detection with the help of depth-first search. So let's get started. Just going to create a Java project with the name, for example, cycle detection DFS. Okay, some typos of course, cycle detection DFS. It's going to be just fine. I'm just going to create three classes. The first is the app.java, from where we are going to test our application. For example, the package name is going to be com.myname.cycle whatever. I'm going to right click the package and create another class for the vertices. It's going to represent the vertices in our graph. And I'm going to create another class with the name cycle detection. Okay. In the vertex.java class, we just have to create a name for these vertices, so private string name. We have to create two Boolean variables. The first Boolean is going to check whether we have visited that given vertex or not. It is like we have seen for any other graph traversal algorithm, such as for the depth-first search or for the breadth-first search. But as we have discussed in the theoretical section, we have to store another reference to a Boolean variable that whether this given vertex is being visited or not. So I'm going to create another private Boolean, for example, being visited. And as we have discussed in the theoretical section, the being visited Boolean can be true whenever the visited is false. Because that given vertex is being visited, we keep traversing the tree-like structure in a depth-first manner. Okay, and we have to store a reference to a list of vertices. It's going to be the adjacencies list. Adjacencies list. Okay, I'm going to have a vertex constructor. In this constructor, we just have to initialize the name. So the name is equal to a string name. And we have to instantiate this adjacencies list as a new array list. Okay, of course we have to import the java.util.list. I'm going to override the toString method. And we just have to return with the name. So return name. We have to construct a method public void odd neighbor. We have already discussing this vertex class, so that's why we just have to implement it. Okay, odd neighbor, and we just have to add it to the adjacencies list. So we just have to add this vertex to the adjacencies list, and I'm just going to right click source generate getters and setters for all of these variables. Okay, Ctrl Shift F to auto format, and let's save it. That's all about the vertex class. What about the cycle detection? The cycle detection, as we have discussed in the theoretical section, is basically just going to do a simple depth-first search. So I'm going to have a public void detect cycles method, or cycle method. Okay, it's going to get a list of vertices, for example, vertex list, and what's the problem? We just have to import the java.util.list. Okay, we just have to iterate through this list. So vertex v in the vertex list. And we just have to check. Basically, this is the standard depth-first search. If this v is not visited, sorry for that, is visited, exclamation mark. So if that given v vertex is not visited, we just have to visit it with the help of depth-first search. And of course, we have to implement this given depth-first search method. So it's going to get the vertex as a parameter. And we just have to set this vertex, so vertex.set being visited true. So we keep visiting this vertex. We haven't visited it, so that's why we do not set it to visit it, because it's not true. We just know for certain that we start visiting that given vertex, so it is being visited. Okay, then we have a for loop vertex v on the vertex.getAdjacencies list. And here we just have to check that if this vertex is being visited. What does it mean? That basically this is a backward edge. We keep visiting a given vertex, so we iterate through all the neighbors of that given vertex, and basically if the neighbor is being visited, it means that this is a backward edge. So we just have to return, and I'm just going to print out that system out println that there is a backward edge, so there is a cycle. Okay. And else we just have to check. Basically this is the standard depth first search. This is not the standard depth first search because we have to check on every iteration whether is there any backward edge. But anyways, we just have to check that if that v that is visited is false, which means that if we haven't visited that given node or vertex, we set it to be visited, and we keep recursing into this v vertex. Okay, so basically that's all about it, and what's very important that after the for loop we have to set the vertex.set being visited to be equal to false, and just to be sure that the vertex set visited to be true. Okay, we set here the vertex visited true, but anyway, just to make sure that after we have considered that given vertex, we set being visited false, because we have already visited that given node, so we are done. So that's why set being visited is false, and the set visited is true. We have done with that given vertex. Okay. So that's all about cycle detection. I'm just going to make some system out printlns to be able to check it, that whether it's working fine or not. For example, dfs on vertex, and we print out the vertex. Okay, here I'm just going to print out that visiting the neighbors of vertex plus the vertex. Okay, then we basically print out that there's a cycle, and here I'm just going to print that system out println that visiting vertex plus the v plus recursively. Okay, some spacing maybe. And here at the end I'm just going to print out that set vertex plus the vertex plus set being visited false and visited true. ... Let's save it, and in the next video we are going to test our application. Thanks for watching.